Good morning, all of you. Welcome to this beautiful course on Docker and Kubernetes. Our course name is Docker and Kubernetes. When I tell Docker and Kubernetes, it's all about containers. Containers. What are containers? Containers are empty boxes. So before going into the discussion, as I begin in every class, necessity is the mother of invention. Who said this? Plato. Plato is one of great ancient philosopher. Okay, he said that necessity is the mother of invention. It means whatever the mankind has invented right from the birth of the human race on this earth till date, they invented the things because of their needs in those particular times. What does it mean? For example, agriculture was invented because to meet the growing food requirements of the growing population. Computer was invented because there is a need for high-speed computation. Railways, airways, all these things were invented because of their need. So need is the mother of invention. Necessity is the mother of invention. Like that, why the concept of containers was invented? Because the software industry was facing a problem. To overcome that problem, the concept of containers was invented. Let's see what was the problem that the industry was facing, how containers could eliminate that problem. Let's go into that discussion. Every software development life cycle starts with development of source code. Development of source code. A team of developers will be there. They will develop the source code. Okay. Once this source code has been developed, it will be stored in the central repositories like GitHub, Bitbucket, Azure Repos kind of repositories. Okay, that is fine. Now the requirement is that the developer has Windows machine, but he needs Linux machine to develop the source code. You got my point, right? So this is a developer. Developer 1 is there. He has Windows machine with him. Windows machine with him. Now what he needs? He needs Linux machine to develop the particular source code, because that is the dependency that he has. Okay, only on Linux that will be developed, only on Linux that can be tested. So now he has Windows machine. This is the hardware with some configuration. Let's say RAM of about 32 GB and CPU of, let's say, 8 CPU. Okay, now let's take this. Now his machine is Windows machine. Okay, this is Windows. In order to get the Linux, there are two choices. One is you can go to hardware shop and buy the laptop and install Linux there. Okay, but he has enough resources in his laptop. Can he install Linux in the same hardware where Windows is running? Yes, he can. What's the tool that can be used? It is a tool called Hyper-V. Okay, Hyper-V. Let's say Hypervisor in general. Hypervisor has to be installed. Hypervisor enables us to create multiple guest operating system on top of host operating system, that is Windows, which is present in the same hardware. Got my point, right? So I have Windows machine and I have enough resources. What I want to have Linux machine. For that, I have to install hypervisor. This hypervisor will enable us to install Linux operating system. And this Linux operating system is called as guest OS, guest operating system. Guest operating system, and this is Linux in our case. More specifically, let's say it's a Ubuntu. Okay, this is. Now, if you want to another Windows machine, you can install Windows as a guest operating system here. If you want to have Mac, you can do that as well. Okay, so now what we are doing here is, now we got the Linux machine. Now this developer one can successfully write the code and test it in his own machine. Now let's say the application name is YAP1. Application name is YAP1. Okay. So in order to YAP1 here, in the sense it's a source code. After that, this source code has to be saved in some central servers. Okay, that is called GitHub, let's say, for simplicity. GitHub. We are storing what? We are storing this source code. Now, in order to develop this application, let's say this is a Java application, we should install necessary dependencies. Okay, dependencies, let's say. Okay, dependencies we have to install, then only he can develop the source code and he can test in his machine. Okay, one feature he has developed, that's fine. Now only we have transferred the source code from this machine to the central repo. Now what we have to do, we have to deploy that machine into QA environment. Okay, the same source code, that is app1, has to be deployed into the QA machine, QA environment. QA environment, it's a testing environment, right? It is deployed here. Here the application is successfully running. The developer ensured that the application is successfully running. Then only this source code has been pushed to the central repo. This has to be deployed into the QA environment. Here, what we need to have, we should have the same environment, or else this can be Windows machine, or it can be a Linux machine, and we have to install these dependencies here as well. Okay, that you remember. Now, what happens even after installing the operating system and the dependencies in this QA machine, the application failed to run. This application failed to run. Why it failed to run? Here also the same source code that is successfully running. Same source code has been transferred to the GitHub, and same source code, same application has been deployed into the testing environment. The application which is successfully running in the dev, why it's not successfully running here? Why it failed in the QA environment? There are two or three reasons. One is the operating system that is there in the dev is may not be same as that of QA. Other words, the operating system that is installed in the QA machine may not be same as that of dev. So due to differences of operating system, the application may fail to run here. The application may fail to run here. That is one thing. So in that case, what we can do, we can create the same operating system here as well. That we can do. Okay, that's fine. Here also it's a Ubuntu operating system. Here also it's Ubuntu operating system. But there are different kinds of Ubuntu operating systems. Different versions are there. 22 is there, 20 is there, 18 is there. So let's say here it may be 18, here it may be 22. In that case also, due to compatibility issues, the application might have failed to run because of these operating system version conflicts. That can be one thing. Let's say the same kind of operating system we are installing, because what I found out that may be the problem for the application to be failed in the QA environment. So let's take Ubuntu 18 here itself. Here also let's take here also it is Ubuntu 18. So same operating system we are getting here, and one thing is operating system, some way we managed to install the same operating system in the QA and dev environment. Okay, so same source code can be deployed here, but still even after installing the same operating system, same version, still our application has the possibility to fail. Why it failed? Please remember, for the application to run, dependencies also should be there. Where I'm installing that dependencies as well. There may be several dependencies, 3 or 4 dependencies for the Java. If you want to install OpenJDK, there are different versions of the OpenJDK. Okay, here it can be one version, here it can be another version. Because of those issues also, there is a possibility for the application to fail in the QA. Okay, now what happens? Developer will show that that application is successfully running in his machine. QA people will tell that that is not successfully running. Okay, so finally DevOps engineers has to suffer. Okay, some operation engineer has to suffer. Why? That's fine. Developers, if you see into the developer's laptop, that application is successfully running. But coming to QA, the same application has been deployed, but it failed to run. Why it failed to run? One can be Ubuntu, the operating system issues, other can be dependencies issue. Okay. Now, imagine a situation where we can transfer application along with its dependencies. We can transfer the application along with the dependencies and operating system environment also. Okay, we will talk about that. Now, in this case, what we are doing? We are shipping the source code along with the dependencies from the dev machine to the some repository, and the same will be deployed. Now it will be stored in some central registry. Okay, that more specifically we will talk later. Now, if you see here, now let's say, now we have eliminated the conflict. We have eliminated the conflict because same dependencies we are copying from the dev machine to the QA machine. So there is we have reduced the most of the problem. Anyway, we can install the operating system. Okay, that's not a problem. And so the same environment, this is called as the environment for the application one. Same application along with its environment has been shipped to the dev machine, to the QA machine. So with that, we have eliminated the problem. And this concept is called as what? Containerization. Containerization of the application one. So what is container? Container is an empty box. If you see, containers are everywhere. These are called as the containers. We will understand. We will go to the shipping example. Now, see, in case of this hypervisor, what happened? And one more thing is that I want to run application A, application B, and application C in some isolated manner. For that, what we do, if we install hypervisor for application A, you have to install full-fledged operating system. Let's say this is Ubuntu. You have to install full-fledged operating system, full-fledged Ubuntu operating system. Here in this case, you have to install full-fledged operating system for application B. So even if you install them, what will happen? Still, you can only transfer the source code, but not these libraries. Now let me come here. So now what we have done, we are able to successfully copy the environment of the application along with the application source code from one environment to the another environment. If it is running successfully in the dev machine, it will be successfully running in the QA machine because same application, the same environment has been copied here. Once this is done, and the same box can be deployed into the production environment without any issues. This is the setup. And now if I come to here, now you see here, in case of hypervisor, if you want to run multiple operating systems, we have to install full-fledged operating system. Okay, same way we can achieve in containers, but in a different way. So for example, here we are installing hypervisor. In case of containers, we install Docker. What is Docker? We have to understand that. I will teach you. Docker is a containerization tool. Docker is used to make the containers. Containers are nothing but small virtual machines. But if from here to here also application A is running, here also application A is running, here also libraries are there, here also libraries also there. But the difference here to here is we have eliminated the need for installing full-fledged operating system. And if we have eliminated that, from where this container will make utilize of the kernel, it will utilize the underlying kernel. Okay, that will be Windows subsystem for Linux. So as of now, you leave it. I will come to that little bit later. Okay, so this is the earliest. All things you have to remember from here is that in case of containers, we are able to successfully copy the application along with its environment from one machine or from one environment to the other environment. So if the application is successfully running in the dev environment, it will be running in the QA environment. From there, the testing is done, then it can be deployed into the staging or UAT or production environment. That is fine. Now, let's understand the concept of containers in detail. Now, let's go to the shipping industry. Let's say. So here one thing is that this application A is isolated from the other application. Why there is a need for isolation, I will tell you. Let's take a ship owner is having a ship of capacity 100 tons. of capacity 100 tons. Okay. Now a customer comes to him. Let's say a customer comes to him. Customer's requirement is that he wants to transport is 3 tons of fish and 2 tons of raw material. 3 tons of fish and 2 tons of raw material from Sri Lanka to Maldives, from location A to location B. In this case, this customer comes to the ship owner and tells that he wants to transport this material from one location of the world to the other location of the world. Let's take it's from Sri Lanka to Maldives. Okay. Now, if you observe, fish requires different kind of environment. Raw materials requires different kinds of environment. Fish requires cold storage. Okay. Raw materials requires dry environment. Now, let's say what this ship owner will do. He will put the fish. He will create some ice. He will create some ice. He will create some ice here. Okay. Let's say this is ice. This is some cold storage. Okay. So in this ice, he will put what? He will put the fish. Next to it, he will put the raw material. Okay, you just separated. Okay, then there is another customer also comes and he may wants to transport some other material. Okay, so like that total he can transport to maximum of 100 tons. Now let's take only this customer. In this case, what is happening is, while the ship is in transit, there is a possibility of mixing of fish and raw material. Fish is in cold storage and there is a possibility of ice and raw material mixing together, and fish and raw material mixing together. After some time, what will happen? These two materials gets spoiled. Okay. So to overcome this problem, the shipping industry came up with the concept of containers. What it did is, shipping industry created empty boxes. Let's take each box is of capacity 1 ton. Let's take the total capacity of 10 tons. So that's fine. This is fine. They have created similar boxes called containers. Each is having a capacity of 1 ton. Now what they did is, for fish, they took 3 boxes, 3 containers, and they filled this with the ice. Here also they filled with this the ice. Here also they filled with the ice. They put the 3 tons of fish. Let's say 1 ton of fish is put in this, and 1 more ton of fish is put in this. Total 3 tons of fish has been put into 3 different boxes, 3 different containers. Now coming to raw material, they took 2 boxes. Why? Each box is of having capacity 1 ton. So total there is 2 tons of raw material, and they will put the raw material in this. Okay, they will create that raw material environment in this dry storage. Now what they did is, they have put this into the ship. Okay, you forget about this. This is the existing setup. Now what they have done is, now let's delete this. Now what they have done is, they have put this, they are transporting like this. Okay, and this won't be available here. And so let's check same thing, second box, third box. Okay, and this is what chronicle box. Now what happened? These containers are completely isolated from each other. So if you come here, see, there is a possibility of mixing and they both will be spoiled. But in this case, everything is put in the form of boxes called as containers. The form of boxes called containers, and these containers are being shipped like this. See, these are the container ships, cargo ships. Okay, so container is an empty boxes. So they will put the materials, goods in the boxes. Okay, so now if you see, the containers are isolated from each other. There is no possibility of mixing and spoiling. And at the same time, they are utilizing some common resource called a ship. Okay, they are isolated at some levels and they are using the common resources of the ship. Now you can imagine the fish has one application, raw material as one application. So this can be Java application, this can be Python application. Now they are running in the same machine and they are running in different boxes in the form of containers. So there is no possibility of process interference. Okay, so if you can, let's say you have two Java application, this Java application will be running independently of this Java application. It will have its own OpenJDK version, it will have its OpenJDK version. Okay, so that is what the container says. Same way here in the concept of our software containers, so applications are running inside the containers and they are isolated from each other. Okay, now how these containers will be created? For that we have a tool called Docker. Docker is a containerization tool. Containerization means the process of creating or making containers. Okay, called what? Containerization is called containerization. Then what is container? Container is an empty box. At this class, you just remember container is an empty box. Okay, slowly we will refine this definition. Container is an empty box. So here if we run the containers something like they are virtual machines, and you can run multiple containers in the same host machine, and in the containers you don't need to have the full-fledged operating system. This is Ubuntu container and this is another container, this is another container. Even if you have 3 Ubuntu machines, these 3 Ubuntu machines will utilize underlying Ubuntu kernel. Okay, If it is Linux machine, okay, then you no need to, that Linux kernel will be utilized by the containers. If it is Windows machine, we have to install the Linux Windows subsystem for Linux kernel. Okay, so finally what I'm telling here is, from hypervisor to Docker, we have eliminated the need for installing full-fledged operating system. And if that is the case, these containers will be booted up in no time. If you want to install and boot up this case operating system, it will take about 30 minutes. But in this, within seconds, we can boot up these containers. We will see that in practicals. And one thing here is, to install this case operating system, so much of system resources will be utilized. Okay, because this is also a Ubuntu full-fledged operating system. For that, we should have RAM and memory and CPU and disk space. For this also, we should have that much of memory and disk space as if we are installing full-fledged operating system. But this is also just to install this operating systems only, we are consuming a lot of system resources, but only less amount of system resources are available for running this application. But if you come to containers concept, what happened here? We are not installing full-fledged operating systems here. Instead, these containers will be utilizing the underlying operating system. Okay. So, and one thing is that even if you can run tens of hundreds of containers, only those 100 containers will be, then 20 containers will be using underlying Linux. But if you want to run 20 applications here, we have to run the 20 operating system, full-fledged operating system. By that time, system resources will be fully utilized. After 3 or 4 installations itself, system resources will be over. Okay, that is one thing. And till date, we have only Linux-based containers. We don't have Windows-based containers. That is one thing. And one other thing is that these containers will be using underlying operating system kernel or underlying operating system. Whatever the Linux machine is not able to run, that containers also can't run that application. That means what we are doing, this is a Linux machine, okay, Ubuntu machine. We are installing Docker in this. This is Ubuntu. And we are installing Docker in this. Docker in this, okay, and we are creating containers. We will see this, all these things practical, then only we'll understand clearly. Now, I want to run some application. I want to develop or run or deploy some application called X. Okay, and this application is not able to run in Ubuntu machine. It has some other requirements. If it is not running in Ubuntu machine, okay, in general Linux machine, we can't containerize it. It also fails in these containers. That means whatever that we can run in the Ubuntu, those things only we can run in the containers. Okay, so if you are not able to run this X application in Ubuntu, we can't run that in the containers also, because finally containers will be using the underlying operating system. Okay, that is fine. Now, let's understand few terminologies of the Docker. And before going to that, let's introduce you to the tool of Kubernetes also. If Docker is creating containers like this, what Kubernetes does? Kubernetes is container orchestration platform. platform. That means Kubernetes is a tool to orchestrate these containers which are created by the Docker. What is orchestration? Orchestration means the process of automating the deployment, scaling, networking of containers is called as what? Container orchestration. And that container orchestration can be achieved using a tool called Kubernetes. Okay, that we will understand after Docker course is completed. Okay, so now you understood finally this is the difference from hypervisor to Docker. If anybody asks you what's the difference between the hypervisor and the Docker, if you use hypervisor, okay, we have to install full-fledged operating system. But if we use Docker, there is no need to install full-fledged operating system. Instead, these containers will be utilizing the underlying operating system kernel. And in case of hypervisor, you have to, if you want to create this, install this operating system, you have to dedicate the resources upfront. That means if your total RAM is 32 GB, you have to dedicate some 4 GB upfront to this. Even if the application is not running, even if the application is requiring only 250 MB, okay, we have dedicated 4 GB, and that can't be utilized for the other virtual machines. Okay, and this application we can't use this. Whatever that is dedicated for this virtual machine, that can also be used by this application. What if the application A is smaller and application B is bigger? Application is not at all using that 4 GB. Application B is now lack of resources. Okay, but in case of containers, we don't dedicate the resources upfront. Instead, these containers will be utilizing the system resources as much as they require, and we can also put the limit also. We will see that going forward. Okay, so now let's understand. And this is the notes, friend. We have about 70 pages of the notes, Docker notes, and we have about 100 pages of Kubernetes. Few more pages have to be there. It will be there in some other documentation. I will give this entire notes to you. In real time, you can use this notes with directly. You can use. Okay, Docker also, every command will be there in our notes. Okay, every command, and we will cover Docker file, which is very important for both developers and DevOps engineers. Okay, we will cover Docker files. We will write various Docker files. We will cover Docker Compose. All those things, different concepts of the Docker. We will cover different concepts of the Kubernetes. We will cover. Okay, and one thing is that all the things will be a real-time situations only. Okay, and one thing is that, yeah, that's fine. Okay, so now let's understand the what is Docker, what is container, what is host, what is image, all those things. Let's understand first. Docker is a containerization tool. Okay, and before that, I want to teach you what is image. What is image? More specifically, Docker image. Image means, let's say you want to install Ubuntu operating system in your machine. Okay, forget about containers and everything. Ubuntu 18.0 you want to install in your hardware or some in our hypervisor. What we will do, if you search for whether it can be Ubuntu 18, 22 or anywhere, any operating system, we have to select an image. Okay, so if you come here, it can be, let's say this is ISO file. It is of 2.3 GB. So in order to run Ubuntu operating system, we should have Ubuntu operating system image. Okay, from image, we will run the operating system. In Docker also, we have a term called Docker image. Docker image is nothing but application along with its dependencies packed together in a file. Then that is called as what? Docker image. Okay, that means what we said, if you come here to our notes, so here we are running some application A. Okay, here also we are running application A. This application A, along with its dependencies or libraries, are packaged together in a file. Then that file is called as what? Image. Okay, so in case of Docker image also, Docker image is nothing but application in the sense application source code along with its dependencies packed together, okay, wrapped inside a file. Then this is called as what? Image. Okay, this is called what? Docker image. So we have this image. Let's say that is fine. This is Docker image. Now we will download this Ubuntu operating system and we will run the operating system from that. Same like in this case, if we run this Docker image, then we will get the Docker container. We will get the Docker container. In this container, this application will be running in this environment. So that means what? What is Docker container? Container is nothing but runnable instance or running instance. Running instance of what? This Docker image. Running instance of Docker image is called as what? Container. Running instance of this Docker image is called as what? Container. That means this is image. We are just running this. Once we run this, then that will become container. Inside the container, this application one will be running. That's the difference between Docker image and the container. So to create this Docker image or to run this Docker container, okay, we have to install this Docker in some machine. Okay, let's say we have the Ubuntu machine. To work with these containers, we should install what? Docker in this. So this is a Ubuntu machine. This is Ubuntu laptop. It can be Ubuntu or it can be Windows. In Windows also we have the Docker desktop. So this is Ubuntu. Once we install Docker in this machine, then this machine is called as, Docker host. What is Docker host? The machine in which Docker is installed is called as what? Docker host. Docker host is nothing but it's a Ubuntu machine, but Docker is installed in that Ubuntu. Then that is called as what? Docker host. Docker host means machine in which Docker is installed is called as what? Docker host. That is one term you have to understand. Okay. Now let me go to my notes and if I want to miss anything. So Docker image is a combination of binaries which are necessary for one software application along with that application, and Docker containers When the Docker image is executed, then it is called as what? Container. Docker host means the machine in which Docker is installed is called Docker host. Then what is Docker client? Docker client means if we want to interact with this Docker, which is running in this inside, we should have some CLI. Okay, we are talking about Docker client. Docker client is nothing but Docker CLI, Docker command line interface is called as what? Docker client. So we will execute Docker commands using this Docker CLI. Do we need to install this Docker client separately? No. If we install Docker, automatically Docker client also will be installed. Okay, that is what Docker client is. Docker client is. Okay, so in Git Bash, if you use the line expression, then Git Bash can work as Docker client. That means we can execute Docker commands there. Okay, that's fine. We will see that. So this is the Docker host. This is the client. And one more thing, registry will also should be there. Okay, registry, or more specifically, container registry. Container registry is nothing but central server where Docker images are stored. Okay, container registry is nothing but it's a central server where Docker images are stored. By default, it is hub.docker.com or simply Docker Hub. Docker Hub is nothing but a place where Docker images are saved. The place where application source code is saved is called as what? Repositories. But the server where Docker images are saved are called as what? Registries. What's the difference between the repositories and registries? In repositories, only source code can be saved, but not Docker images. But in registry, only Docker images can be stored. That's the difference. So container registry is nothing but what? The central server where Docker images are stored. So if you take AWS, I forgot to delete the clusters. If you take AWS, Elastic Container Registry. Okay. This is the registry. If you take Azure, Elastic Container Registry is the registry which is provided by the AWS. If you take Azure Container Registry will be there. Okay, so different cloud services are providing different registries. So the registry is a place where Docker images are stored. By default, public registry is hub.docker.com. So if you want to get Ubuntu, see, this is the Ubuntu image. So in registry, Docker images are stored, not the containers. When these images are downloaded into the Docker engine, Docker host, and if we run the containers from the image, then that is called as what? Containers. Okay, so in registries, images will be stored, not the containers. We will download the Docker images from the registry to the Docker machine, and there we will run the container from that. This is what introduction, friends. This is the demo one. Let's meet tomorrow at 8 AM. I want to just briefly tell you about the course details. Somebody is asking, sir, without knowing AWS, we can learn Docker and Kubernetes. Yes, very good question. The prerequisite for this is You don't need to have any prerequisite, but it's good to have some Linux knowledge. Otherwise also no problem. I will teach you those Linux commands which are related to this. Nothing, no more commands won't be used. Okay. The course name is Docker and Kubernetes. Okay. Duration is 45 days and timings are 8 a.m. to 9 a.m. Okay. Weekdays from Monday to Saturday. Then this is IST, friends. This is IST, Indian Standard Time. UTC plus 5.5 hours. Then this course fee is 4,000 INR. Okay, and one thing is that what you will be provided: live classes plus recordings will be provided through Google Drive, and plus notes also. Every day I will upload the notes. Okay, these are the course details, and they have provided the. Somebody is asking, is this course targeted mainly for DevOps or is it for developers as well? Developers also is very important. For example, nowadays, who writes the Docker files? Developers has to write the Docker files. Okay, this course is targeted mostly with the DevOps, but this Docker is also very important for the developers. And nowadays, some companies are also asking Kubernetes knowledge for developers as well. But this is for more target oriented for the DevOps engineer. Whether it can be DevOps engineer or developer, Docker is means that Docker both has to learn the same thing. Okay, that is. And Viraz is asking, so session is for all days. All days means what? It's for Monday to Saturday. Are all demo courses same? No, we will continue the course. No, tomorrow we will continue the continue this, but you will be eligible for free, and after that you will be asked to pay the price for this. Okay, so after 2 or 3 classes, this link will be disabled, and for people who have paid, new thing will be there. And tomorrow we will continue from where we have stopped. Somebody is asking, my job timing is 24/7. Due to this, I'm not able to join regular. Can you please provide videos material? Yes, definitely. Videos and material will be provided every day. Job timing is 24/7 means so you are working all 24 hours. Just kidding. I think you are working in shifts. That's fine. You will be getting the recordings through Google Drive. Okay. You're selling, it has a shifts. Okay, that's good. Okay, and you can watch the recordings. You don't need to worry about that. This is what all about. And in next demo, what we will do, demo in the sense it's not something like today will be repeated. No, we will continue today's class from today's class. That's it for this class, friends. Thank you very much. If you have any doubts, and in the chat they are pinging the WhatsApp, that Google Pay numbers and everything. So that is there in the chat box. So please look at that. Thank you, friends. If you have any other doubt, you can ask me. Otherwise, we can wind up this session. Somebody is asking. Yes, thank you. I'm mainframe technology. Can I switch job by attending this? Yes, you can switch. But DevOps contains other tools as well. By just learning Docker and Kubernetes, you can't switch to developer. There are some projects, there are some companies where they will take only Kubernetes engineers. That's fine. But if you want to move completely to DevOps, so I suggest you to learn AWS, and along with that, other tools like Jenkins, other things as well. Yeah, Viraj, the syllabus is, I think it will be published in the portal. It is already there, if I'm not wrong. So please check there. Okay. It will be there for sure. Okay, friends. Thank you. If you have any doubts, so course is very affordable. and you can opt for that. You will be getting what you are expecting. For videos material, where can you no need to contact me. They will share you a link. Okay, admin people, the institute people will share you the Google Drive once you have paid the price for it. Yeah, and again, Viswal. Yes, hi. Anything to ask? I have done AWS benefits for me. Yes, if you are done AWS, it will add more value to your profile. Yes, and generally what people are doing is that I'm just telling. Yeah, you can speak. You can unmute and you can speak again.
Good morning, sir.
Yeah, very good morning.
Yes. So, sir, I am working in a company. So now I have 1 year, less than 1 year, 8 months experience. So I want to move to DevOps career. So I want to learn in part by part or in full course. I have to learn DevOps or part by part. Like I have to learn Docker, Kubernetes, then AWS, then DevOps. So what is the main? What is the type? Which type is better to learn?
Yeah, I suggest you first you learn a cloud. Let's say AWS or Azure, whatever it may be. Okay.
Okay, sir.
Then after that, you have to learn DevOps. As a part of DevOps, not just this Docker and Kubernetes, you have to learn Jenkins. You have to learn Docker. You have to learn Kubernetes. You have to learn Git and GitHub, and you have to learn Ansible and this is Sonar Cube. Okay, Prometheus, Grafana, ELK. Then what else? You have to learn Linux. Then what you need to learn? What are other tools that we have? We have different tools, right? These are enough, and some people will be using, some projects will be using Chef, and some people will be using Azure. So like that. Okay, there are different tools are there for Jenkins. The alternative to the TeamCity is there. Azure pipelines is there. Apart from this Docker, we have Rocket is also there for containers, but Docker will be mostly used. And for Git and GitHub, we have Bitbucket and all those things are there. Anyway, that commands will be same. Ansible is there, Chef is there, Puppet is there. So Sonar Cube is there. Then for monitoring, NagoorBabu is also there, apart from this. So different kinds of things are there, right? So you have to
Yes.
learn all those things. If you learn all those things, generally what will happen is that if you opt for the course, they will be teaching, they will be telling that in 2 months, DevOps will be completed in 2 months, AWS total 4 months. For AWS and DevOps, total 4 months. In that 4 months, can we expect this Docker and Kubernetes a full-fledged course? They will just introduce you to this. I'm not criticizing them. So they don't cover this in depth. So
Yes.
this course is for people who wants to learn Docker and Kubernetes in depth at the real-time level, and provided and one thing, believe me, that if you are opting for DevOps, if you go to DevOps interview and if you tell that you have the knowledge of Docker and Kubernetes, and these tools have more weightage because there are only few people who have the knowledge of Kubernetes. So if you are learning Kubernetes, then you will be having some edge. Okay, so if you're learning Kubernetes means you will learn Docker, you know Docker, you will have some other things, so you can learn easily.
Okay, sir. Sir, I already learned Linux shell scripting, DURGASOFT class. So in my projects also I am using Jenkins and GitHub. So is that early I can start a DevOps course or not? Because it will help to me in my project also, and as well as my DevOps career.
Yes, it is always helpful. If you go to DevOps job, if you want to opt for it, so as a part of DevOps, some people will ask Jenkins, Kubernetes, Docker. Okay, some people ask also, some projects may be using Ansible.
Yes.
Okay? So based on the project, the requirement will there. So you have to learn all the tools. Okay.
Okay, sir.
That's it for today, friends. Please, I recommend you to opt this course. Thank you very much. Thank you. And somebody has right. Yes, yes, you only right. Okay. Yes. Thank you, friends. Let's meet on Monday. Bye.